All right, here we go. So thanks to Josh and Louise for bringing up that our Delta Math today has some unexpected dabbling in the concept of second derivatives. So if you look at this problem here, we've got f of x is negative x to the fourth plus 16x to the third. Determine all intervals on which f prime is decreasing. So what we've talked a lot about is that f of x is decreasing when f prime is negative. And the corollary to that is that f prime of x is decreasing when the second derivative, when f double prime of x is less than 0. Because that is the slope of the tangent line. If you were to graph the first derivative and find its derivative, that would tell you when f prime is decreasing. So what this problem is actually asking you to do is to take f of x, which is x negative x to the fourth plus 16x to the third. First, you have to find the first derivative. So this is going to be negative 4x to the third plus 48x squared using the power rule. And then we have to take the second derivative doing the power rule again to get negative 12x squared plus 96x. And now we're ready to do our sign chart on the second derivative. We want to know when the second derivative is 0. So we can factor out a negative 12x. And so this is going to be negative 12x times x minus 8. And so our two locations to make our sign chart of the second derivative are at x equals 0 and x equals 8. And so we're going to make our sign chart here. We have x equals 0 and x equals 8. If I want to know when f prime is decreasing, I need to know when the second derivative is less than 0. The only thing I know right now is that the second derivative is 0 at those locations. I need to be able to fill in what is happening at these three places between or after those critical points. And so we can do this by just thinking out some mental math. We'll do these color-coded. Let's pretend we plugged in 10. So if we plugged in 10, we're talking about the green one. If we plugged in 10 to the second derivative, we'd have negative 12 times 10 minus 8. Now, I don't really care what this is. All I care about is this is negative 12 times 10 times 2. All I care about is that this is a negative number. So the second derivative will be negative for all numbers above 8. Between 0 and 8, so say we plug in, let's say we plug in 1, might as well make it easy. We'd have negative 12 times 1 times negative 7. Now we've got two negatives to make a positive. So on this interval, the second derivative is positive. And finally, left of 0, so say negative 1, we'd have negative 12 times negative 1. Negative 1 minus 8 is negative 9. Now we have three negatives, so we're back to a negative number. And what we cared about when is the first derivative decreasing, when is the second derivative less than 0. The second derivative is going to be less than 0 on these two intervals on the ends here. Now, Delta Math is pretty picky when you use the brackets. So I'm actually going to use, instead of using the brackets, I'm going to use greater than, I'm going to use inequality notation. So I'm just going to say this is true in two places. This is true when x is, where do I find that? Functions. Here we go, shift, when x is greater than 8 and when x is less than 0. That's a lot easier than using that bracket notation, in my opinion, for those ones. Hopefully I haven't made sort of a silly mistake here. Let's see what we have. Woohoo! All right, good. So again, when you're trying to find if the first derivative is increasing or decreasing, you want to find whether the second derivative, the derivative of the derivative, is negative or positive. And you can either do Delta Math's notation there, or you can do inequality notation, which I find a lot more intuitive than saying 8 to infinity like that.